Hey folks, welcome to another video. Today let's discuss a bit about distributed tracing, namely in .NET and .NET 6. So it's not a new topic, but there are some new interesting things going on, so let's take a look. So just as a quick intro, distributed tracing is very useful when we are in this world that we are right now, building microservices, distributed systems and all that kinds of stuff. And we want to relate the things that are happening in the system. So for example, a user makes a request to our web application and that causes a bunch of requests to other services, stuff like that. And it's interesting for us to help us debug and find issues on the applications. We can relate everything from the start of that request to everything that it impacted. So as I said, this is not new. If you are building applications, for example, in Azure, there was already application insights. Even in there are other vendor-specific offerings, like I used in the past, Elastic Stack, which has an APM, application performance monitoring solution, which includes distributed tracing. So it's not something new. But today I want to talk specifically about some new standards that have emerged in the last couple of years, namely W3c Trace Context, which is like a standard for propagating that context, that tracing context as it's in the name, between all the services. So when we start, one service calls the other. So this is a standardized way to pass information. And basically, I'm not going to go into a lot of detail, but imagine that we have like an ID for the trace itself, and then we have like an ID for each step of the trace, which normally is called span, not in the standard itself, but in other cases it's typically called span. So trace is the whole thing, and span are the various things, like a span is within one service, and then the other service as another span, that because it was called by the first one, it's like a child span of the first one. So if I go somewhere, I will find in here talking about the stuff that go inside of it, and we have the trace ID and the parent ID, so the parent span. So this is one of the things that is kind of new. This is like recommendation from 2020. And also another thing that's recent is OpenTelemetry, which is a standardized way to implement this distributed tracing collection of information and then representing it. So these are things that are rather new. And for example, OpenTelemetry.net reached 1.0 in March this year. So it's kind of new. And what's interesting is that it's built into the framework, and we'll see how. This support, we need to add some external packages, but the thing itself, the way to collect this information has been baked into the framework. So it's easier to integrate not only with OpenTelemetry, but eventually with other things. It's probably also possible. And yeah, and what's great about this is standard, so no vendor lock-in, so you don't need to be locked to application insights or Elastic or whatever. You can use OpenTelemetry and you can use it anywhere. So for example, if you use application insights, as far as I'm aware, I think you can import OpenTelemetry data that you collect into application insights. So if you are in Azure, you can create your services like using OpenTelemetry to make them not vendor locked in, but then use it with application insights. And then at some point you want to go somewhere else, some other cloud or on-prem or whatever, you don't need to change your application, or for that reason at least, because it's OpenTelemetry. You can just then export it somewhere else and it will work. So let's see how with this support in .NET, in the Asp.NET Core 6, now to use these things more in terms of OpenTelemetry, not so much in trace context, because it's like underpinning all the things. We don't really see it a lot, but I'll show you in a bit. So let's take a look at that. I have a bunch of things, but I will show you along the way. So let me hide the picture in picture, and let's take a look at the demo application and the code. Let's go here. So the sample application is the simplest thing ever. It's just an excuse to see things in action. So let's start by seeing it in action. We just have a text box, we put a name, and we get hello name. So this is not interesting. What's interesting is that to get to this, I over-engineered the hell out of this, and we have 4 different services that are working. So we have the web client, which is this application that we saw. We have a web API, which this web client calls. It's just a web API. We call with a get or post. I don't remember. We'll see. Then the web API calls a gRPC service, just because of reasons. And it also sends a message through RabbitMQ that the worker eventually processes. So it's a bunch of stuff going on that it's completely unnecessary, but good for demo. So let's quickly start with the application. Let's go at the program CS. Just for the first thing is that the first time I did this this code, I prepared it. It was still in Asp Net Core 3.1. And at that point, the W3c Trace Context format of the storing things was not the default. At this point, I don't know if it was in 5 or in 6, but now it is the default. So I had this code setting the default ID format to W3c, but now it's committed because it is default nowadays, so it's no longer needed. But I prepared this a long time ago. I have this demo in GitHub for like 2 years, maybe. But only now I thought about creating a video. So this is for W3c Trace Context. And before getting into all the distributed tracing stuff, let's take a look at the W3c where we can see it. So I'm just here configuring logging, and I'm using seek for logging for no particular reason other than it was the easiest I found to create like a Docker container to host, because if I wanted to go with Elastic Stack, I needed to host Elasticsearch and Kibana and all that stuff, and I just wanted one container that I could shove all the logs into, and seek worked. So it's the first time I tried it. Seems okay, so maybe I need to investigate more, but in this case it was just for that reason. I just wanted to have a quick way to send logs to a centralized location. So let's take a look at seek, just for us to see this W3c Trace Context show up a bit. So I already made this request, so if we go to seek, we have a bunch of logs. I can, for example, open this log, and let me put here, let's find all related to this trace ID. So this trace ID are all the logs correlated to one request. So we can go to the first one. You can see that, for example, parent ID is 0 because we are in the first part. We will see this better when we see the diagrams generated by the distributed tracing, but for now let's just take a look at the logs. So it has no parent ID. It has a span ID, which will eventually become the parent ID of the thing that's invoked by this one. And we have the trace ID, that's the whole end-to-end request. So this one then made a request to the other service. It's still parent ID is still 0 because we're still in that context. So you see span ID is still the same. So start processing, sending request, and then we have executing endpoint. So in this case, we are this log is from the web API. And in this case, we should have a parent ID, which should match, hopefully, I think. So span ID. No, we will see in the distributed trace, we will see it better, I think. We'll see how it works, because sometimes there are spans created. So a span is not mandatorily like something that happens. For example, the whole request within the web client, it's not mandatorily the same span. We can internally create more spans. So sometimes when looking at the logs, we might find weird that this parent ID here is not the immediately before span ID. But when we look at the distributed tracing diagram, it will make more sense. But yeah, you can see how trace ID, span, and the parent appear here. So this is the W3c Trace Context being stored here and being part of the logs. But now let's dive into the distributed tracing part, which is probably more interesting. So let me go back here. So this is the application. OpenTelemetry, I will open it here. So it's cross-platform standard, all of that, pretty cool. Works with all the things. It's a CNCF project. And we have the OpenTelemetry.net, which is in version I don't know what. So a bunch of things. But let's immediately get to look at it. So this is just, OpenTelemetry is just to capture and export this information, but then we need to use tools to look at this data. Again, as I mentioned before, you could use application insights and probably other things that support it. In this case, I'll use a couple of tools just to show more than one, because they are mostly the same from what I saw so far, which is Jaeger and OpenZipkin. So these are tools that support exporting traces in more than OpenTelemetry format, but support OpenTelemetry format, which is what is interesting for us right now. So let's see. For the same request, as we saw in the logs, let's take a look at how it shows in Jaeger. If I go here, I select, you can see we have a bunch of all the services and Jaeger query. I don't know what this is, but let's select the web client, which is the base for everything, and just find traces. So there are a bunch of things here, because every request that we make is logged by default. So by default, after we configure OpenTelemetry and that sort of thing in the application, of course. But the interesting thing that has all those interactions is this one. And we can see now all these services working together and how they correlate. So we can see we have the web client, which gets the hello request. And then we are still in the web client, but it's in the new span. We have a bunch of information here. So this one, I think, is the HTTP client support for OpenTelemetry, or for tracing in general, that creates this part. And this one is when the request reaches the web API. This one is when the web API is making a request, a gRPC service request. This one is in the gRPC service when it starts to handle the request. This one is like I will show you, but this is a custom one that I created. And then back to the web API, making a database call. This is the Postgres endpoint that it's making a query. And then web API again is sending a message to RabbitMQ and it's also a custom implementation I did. And finally, the worker receiving the request, and it's taking 5 seconds because I put task delay in there just to take longer to see what happened if this task took a long time. But as we can see, it's all here. So let's take a look, for example, over here in the web API. We should have a bunch of information here, like host, HTTP method, stuff like that. Process, I don't know what this is. And there's probably more information somewhere. We can, for example, see this again. This is assuming this, let's say this is Zipkin, so it's similar. Web client, let's say run query. I want more results. Are these the only results? If these are the only results, something went wrong. Last 2 hours. Okay, there's this span here, should be the same. Let's see the URL, C88, C88. So it's the same thing, it's just in a different place. So if we see web API here, bunch of stuff, show all annotations, and see a bunch of stuff. We can see the span ID here and the parent ID. So let's see. So this parent ID here ends in 8F3. If we go to seek, when it gets here, the parent 8F3. So we are seeing the same thing. And now we can see that this one, which is a support for the web client, should have here. So the span ID here is 8F3. So it's the parent of this one. And this one is the one that we didn't saw in the logs because it's something, it's the support from the HTTP client for tracing, and probably doesn't log, and we didn't see it in the logs. So in the logs we might not see everything, but in here we should see all the connections. So you can see everything working together, and I think you can already imagine why this is helpful. I found bugs in applications because of tools like these ones, because I saw that, for example, in one request we were making more database queries than we're supposed to, so we detected these kinds of bugs. So that's very helpful, even in development time. So even more when it's in the server, but even in development time, it's already pretty interesting to use. So, okay, so now we saw what we get. Now let's take a look at how to get this working. Back to Visual Studio Code. Let's see the configuration. So the configuration to get this to work for most of the things that we see here is just configuring some stuff in the startup, importing some NuGet packages and configuring the startup, because it's all like built in. So let me just show you, for example, the CS proj, and using here like OpenTelemetry, instrumentation, Asp Net Core, HTTP. So these are the parts for so the HTTP is what gives us this view, and the Asp Net Core is what gives us this. So whenever we get a request, Asp Net Core, OpenTelemetry is connected this way, and then this way. And then the same for other parts. In the other projects, we'll have something for the gRPC part, something for the database, or in this case, I think it's specific for Entity Framework. But yeah, we can plug it in any way. So if we have a specific library, we can add support for our library as well. So we import these packages. Also, extensions hosting is to give us the extension methods to use with DI, ASP.NET Core's DI. And then we have these exporters for Jaeger and Zipkin, just to have built-in support to shove everything in there. So back here in the program, we can see, so add OpenTelemetry, tracing, and then we can configure stuff. So in the set resource builder, we can, for example, create something. If we don't pass in anything, it will just infer some name, and that's why I use the create default, and then add service name web client, so I can easily distinguish all the services. Then we add the ASP.NET Core Instrumentation. We can add stuff like this. If there are some things that we don't want to be part of the trace, we can filter. That's an example I would put here. So for example, when using, I don't know if it's just, I think it's because of how to reload in .NET 6, it was always making requests to this one, and I was like, let's ignore it. And another thing interesting is that besides the possibility we have to create our own spans for things, for example, like we will see to add support for RabbitMQ, we can also hook up to the existing ones. So I went on debugging and saw that we had like an event called onStartActivity. That's a topic for a few minutes. So let's just continue. I'll tell you about this part. But there's an event called onStartActivity, and we can check if the raw object is a request message. If it is, and we see that it's an HTTP GET request, I'm adding a tag just to see that this works. So if we go back here, and we see here in the web client here, there should be a tag here, random demo tag, adding some random demo tag. So I was able to hook up to the HTTP client tracing capabilities and just shove things in there because of reasons. So it's possible. We don't need to like customize everything. We can just slightly tweak, or we can customize if we want. Then I just have the Zipkin exporter and the Jaeger exporter. You should, when you're in production and you have an actual endpoint for the Zipkin and Jaeger APIs, configure the URI, but it already defaults to the default, so it defaults to localhost and the right port. So don't need to put this, but I just left it here to remember the values. But these are just the default when I created the Docker containers. The default is this. So, and that's all in here. Let's just take a look. For example, in the pages, I think it's in the request is being made hello. And as you can see, I didn't do anything. This is just a client. I'm getting a client making a GET request and getting the output of the response, which is just an output model. And this is because I'm ignoring the nullable reference type stuff. I should either disable it or respect it, but it's a demo code, so I don't care. But as you see, there's nothing related to tracing here because it's all using the built-in stuff that was configured in the program CS. So in this application, nothing else going on. Let's take a look at the API where much more things are happening. So Web API, program. So the Web API, if you recall, we can see here the Web API gets a request from the web client and then makes a request to gRPC service, makes a database access, and sends a message to the worker. And only after that, it responds to the web client. So we have a bunch more stuff happening here. So we have the add gRPC client, add the B context, and then configuring OpenTelemetry stuff. And in here, again, set resource builder, just to give it a name. add Asp Net Core Instrumentation, HTTP Client Instrumentation, then add gRPC Client Instrumentation, and this one is an interesting thing. So suppress downstream instrumentation true. Why is this? Because gRPC client also uses the HTTP client. So if we don't suppress this, we'll have the same request twice because it's the HTTP and the gRPC, but showing in different ways. So when we are using gRPC, we don't care about the underlying HTTP because this gives us enough information, so we can suppress it. After this, we have entity framework instrumentation. If I show you the CS proj, so we have here instrumentation, lots of instrumentation, ASP.NET Core, gRPC stuff, and entity framework, which is not like official, so it's a contrib package, but it worked, so all good. Which means you can do it as well for other packages. And over here, we can configure setDB statement for text equals true. What does this mean? We can show the query, and this again is interesting to see if the query, for example, maybe we are checking that we have a slow request handling. We can see that there's a query, and maybe the query is taking too long. We can immediately see the query and see why it's taking so long. So I put true. So if we go here, see the query, and we see the statement. Insert into hello entries stuff. So it's some basic thing, but this is interesting. Maybe we can figure out issues just by looking at this without even debugging. Just by looking at the tracing, we can see, oh, that's why it's slow, because EF generated a bad query or something like that. Just a side note, if you are using ORMs, it's a good practice to check the queries that are generated. So even if the ORMs are good and your application doesn't have a big performance constraint, it's always a good thing to check if the queries that you are creating are not some weird things that may cause problems, particularly in the future when the database grows. So just a quick side note. So back here, entity framework, then add source. This is when we want to create a source for traces, for spans. We need to put it here, and we'll see why. This is the message publisher, so this is to implement the support for RabbitMQ. And then add Zipkin exporter and add Jaeger exporter. Okay, so we need to go to the message publisher to see it in action, but before, let's go to the even before that. So just for you to see, I'm using the minimal API. So the API gets a hello request, gets the username, then call the gRPC service with that username, insert that username into the database over here, and finally publish the message to RabbitMQ using the message publisher class that I created here. Okay, but before the publisher class, this is a bit more complex. So let's start with a simpler variation, which is in the gRPC client. I created a custom implementation of a span. So let's start with that one before going to RabbitMQ. So I'll keep this open, gRPC service implementation is here. You can see the program as well, but it's more the same. Add Asp Net Core, add stuff, and then add source for the greeter service, which is manually. So let's go to the greeter service. So I think this is like the default thing that the template generates. I just added the custom stuff. So this is what I wanted to mention before. All this thing for the distributed tracing is built into the framework. So this activity source, if we see, is system diagnostics activity source. So it's part of .NET. That's cool because, for example, if you are building a library and you want to make your library a good citizen in this distributed tracing world, You just need to use this, and even if the persons are not using, if the users are not using the distributed tracing, you don't care. You have the hooks. If they activate stuff, it will work. If they don't care. So this is good. The only kind of bad part is that you get used to the naming conventions of OpenTelemetry, like the trace and the span and stuff like that. And then in .NET, it has other names. So a span is an activity. So that's a bit strange. You need to map the namings. But besides that, it works well. That's the most important part. But it's strange, because normally if you are using OpenTelemetry, you would expect for it to have the same names. But yeah, whatever, it works. So if you want to create a custom activity or span or call it whatever, you go here, you get the activity source with the name, and you start activity. And it's disposable, so when it's finished, it stops it's disposed and stops the activity. So it ends the span that you see over here. So this is a custom made one, and this is how do I put this down? Yeah. So it's this one. See, this is the custom span. Doesn't have good information because I just created that. And this say hello. If we go here, it's say hello. So this is that custom thing. Task delay 250 milliseconds for reasons, and return the result. It's done. So for a simple custom span / activity, it's just this. Now for the Rabbit stuff, it's a bit more complex, and let's take a look at that. Back to the Web API, program, message publisher. So the message publisher is just an abstraction I created to abstract RabbitMQ. So I'm using EasyNetQ, which is a bit simpler to use than the default Rabbit library, but besides that, it's not very interesting. So I'll ignore some of these parts which are Rabbit specific, and let's go directly to publish async, which is the interesting part, mixing together the Rabbit stuff with the OpenTelemetry and stuff like that. So as we saw before, for the gRPC service, we want to create a new activity. So we start an activity. We called it message sent. Let me just close this part. And we can pass in an activity kind. In this case, producer. We have more options like client, consumer stuff. I don't know if this is very important to pass or not, but just tried it. And I got this information when I was going through the samples in the OpenTelemetry.net repository. So I used it. So we start the activity. We can see here in the activity, if I collapse this, and we see like message send. So Web API message send is this one. So we are starting a new span or activity, whatever. We're creating message property. This is Rabbit stuff. So if I have 12 is EasyNetQ. So this will be the way we will store the telemetry related things in the Rabbit messages so that the consumer can get them on the other side. So create these properties. Then we grab the activity context. So from what I understood from this part, so the activity context has like the information about the current trace, like the trace ID and the parent ID and stuff like that. And we are grabbing it from the activity that we created, grab the context. If there isn't one, we are going to activity current, which is supposed to be this one, as when we do start activity, it's supposed to be this one, but just in case. Otherwise, default. And we are doing this because it says that it can be, if we check activity, when we start activity, it might be null because maybe we don't, if there are no listeners, maybe no activity is created, from what I understood. So we need to take care of this. in case no activity is started. So we need to consider for this scenario. So the activity context should be like the W3c part. Then there is also this thing here, the baggage, which is where we can store more things. We are not really using it so far, but it's used here for the propagation context, which is what we will use like to propagate the information from this publisher to the consumer on the other side. And we have this propagator.inject that will inject the information in this propagation context, which is created from the activity context and the baggage, and it will inject them into the message properties, which remember is from RabbitMQ. And to do this, it will use this inject trace context. We can see the over here. So because diagnostics and OpenTelemetry, stuff like that, don't know anything about Rabbit, so this is generic. So we get a T carrier, and then we get a setter that will set the values that we get into that carrier. So our carrier will be the message properties, and we pass in a function to set those properties. In this case, we get string key, string value, and we have the message properties. Again, this is for Rabbit, and we will use the headers to put there the information. So if the others are not there, just create a new one and put the key value. So it's easy because it's a dictionary, and it's done. So we put this in the message properties, and then when we are publishing the message to Rabbit, we pass the message properties along with the message itself. I'll just pause or stop the worker so that we can see that if we send another message, and we go here to the queues, and we get the messages, we see in the headers this trace parent that, if you recall, if you go here to W3c Trace Context, trace parent, so it's that thing from W3c Trace Context that takes the trace ID, parent ID, stuff like that. And because we didn't add anything else to the baggage, namely, we have nothing else, but this is where things would end up. So let me just restart this so we see the message being delivered, and it's there. So that's it from on this side. So we use those things, we created the activity so it shows up over here. So it's this activity, it's very fast, but it's this one. And we propagate all those this context, the activity context, baggage, using the message properties. So on the other side, in the worker, we'll have a handler that can extract this from the message properties, so we can start an activity on the other side. So let's go here and worker. So for the program, nothing really interesting, just OpenTelemetry, source resource. Again, add source because it's a custom one, adding the exporters. So then we have a message handler, which is like a background service, just for handling these to be running in the background of the .NET application. And again, ignoring the Rabbit specific things, we have the consume method where we can pass in a function to consume the messages. And now we do the opposite of what we did on the other side. So if you remember, over here we have a propagator inject, and on this side we have propagator.extract. So we get the propagation context using default because we don't really have anything. So on the other side, we were already in the context of an activity, so we were creating like a child activity. So we had something to get from. But in this case, we are in a worker, in a background service, and there's no activity going on here. On the other cases, the activity is like created when the request to ASP.NET starts to be handled. But in this case, we have nothing. So we are doing the same work that ASP.NET does on the other side. We are doing for the Rabbit case. So we are a default, no need, we have nothing. So we grab the message properties because those we receive. This is part of the RabbitMQ library. We got the properties, and we have an extract trace context, which is like the opposite of inject trace context, where we go through the properties headers and try get the values, and we decode those values. If there are nothing, we just return empty. It's all good. So this does the opposite work. Then, as we extracted this propagation context, we can grab the baggage and put it in the current baggage, which should be empty. And then we start an activity on this side. And in this case, the other cases, because we already had a parent activity, we didn't really have to pass anything. But in this case, we didn't have a parent activity. So we need to pass, besides like the label, we are saying that it's a consumer. And then we are passing the activity context. So because it can't grab the activity context that is like omnipresent, I would say. So the activity context that's implied, because it doesn't exist, we are grabbing the activity context that we extracted from the message information. And then I just felt like adding some more information, so I added some tags. So just to see server, machine name. So we can see this activity here. It's this one that takes 5 seconds because there's a task delay here, 5 seconds. And if we take a look at the tags, we see the server, JD Home 0, which is the name of this computer. And then you have span kind, which is that other thing. And these things is just some other information that we could put. So add messaging tags, it's being called over here. So just adding some extra tags directly to the activity. So we can either pass them here when creating the activity, as I did here, or we can add them afterwards, as I'm doing over here. And that's mostly it. So in message publisher, we put things in the headers so we can extract them in this side. And we use this propagator stuff to help us doing this. So not very hard. Some things are a bit weird, like this propagator inject is a bit strange, all this thing. Maybe it probably makes sense. It was probably the best way to do it, but still kind of weird that we pass in a propagation context, some message properties, and then a function to insert things. But yeah, besides at first glance being a bit strange, it's not that hard to understand. And yeah, so these kinds of things probably we would do, let's say, if you are implementing a library, for example, and you want your library to work well in this context. And maybe besides in the library, if you are creating your application and you see that there are some spots where you feel it's more likely that it may become a bottleneck, or you are not sure, or something like that. So for example, in the past I worked on the project and we were doing like document transformations and reading from file system, writing, stuff like that, and we were not sure maybe that place could be like, might be a problem. So we put some activities. In this case we were using another technology, but still we wrapped that up in this sort of pattern so that we could see what was going on. And it was helpful. As I think I briefly mentioned, we found some bugs due to this, like because more queries were happening than we expected and more time was taken right into this, stuff like that. So it's very helpful even in development time, but even more when your application is in production. So that's it for this one. I hope it was helpful to understand how this works and why this is very useful. Let me know in the comments if you are already using these kinds of things, OpenTelemetry specific or other ones. Let me know. Any ideas, any comments, as always. And yeah, these tools are cool. Jaeger, Zipkin, probably, maybe there are some more pleasing to the eyes or something like that, but these seem to work well. And OpenTelemetry as well seems like a good choice. So hope you enjoyed it and see you in the next one. See you.